and we are going to go through the notes for tonight. So going over last week's homework first. The idea was to get comfortable with file output and using the random function that's built into C++. I wanted 1,000 random numbers in a text file called randoms.txt. This is what I was talking about. The way I wrote it was exclusive. So the range I was looking for was -9999 to 9,999. If you didn't do that, if you did 10,000 to 10,000, then that's totally fine. And what I want to show you that it was a little more complicated than I thought it was going to be because of that range. Everybody got it turned in, I think. All right, so here is the code that I wrote to solve this problem. You will see I added some extra stuff that I didn't specify, but because once I noticed that I had those as an exclusive range, I wanted to make sure that my code generated that external exclusive range. And so what I did was I wanted to keep track and make sure that my minimum number was -9,999, and my positive number, my highest number, was 9,999. And so included using the random function. I called the srand, which means seed random, passing in time null. Time null is now effectively. And so that means the random number generator always starts from what they call a seed. The seed is by default is 0. So if you run your code more than one time, you'll see the same random numbers getting generated. And so I seeded this with the current timestamp. That way, every time I ran my program, it would be different. I saw some of you guys saw that seeding function as well. Did that come from Googling? It's an okay answer if it did.
I saw it in a YouTube video.
Yeah.
That's suited for.
Yep. So that's what it does. So that's what, yeah, so seeding is a concept we didn't talk about, but that's what that srand function is. And then the usual stuff we talked about last week, opening my output stream to the randoms.txt file. If I couldn't open it, I return a 1 and a printout saying cannot open the file. Crap. And then, so I generated a 100 million random numbers, just so I know I'd get the full range. But I only printed it out if it was one of the first 1,000. This was me just testing my random number generator, really. And I actually put in a little test in here that said, if my random number is out of range, I'm going to throw an error and I'm going to break out of my loop and finish. Y'all didn't have to do that. That was just me making sure that I got the right range. So this was the formula I came up with to generate between -9,999 and +9,999.
Oh, that definitely goes to 10,000.
It definitely does not.
Don't you add those numbers together? Isn't that 10,000?
It might be. Let's see, where was my homework? Homework 11
Oh,
answer.
that's the second number, right? It does that range, so.
Yeah, let me tell you.
Oh, yeah.
I actually write it on the next slide. I wrote it out. So my randoms. Anyway, so I'll go through the next slide to show you the math. A couple of chat questions. Anybody want to volunteer to read those?
Sure. Well, I'll just ask my question.
Cool.
I thought OFStreamOut was open or create. So like if there was no file, then it would just create one without name.
Yes, it is.
Okay. Just wanted to double check.
Yep, but there are conditions when it cannot open a file. So if your disk is full, or if you don't have write permissions to the folder you're running it in, so there's still those conditions.
Okay. Yeah, I didn't think of that.
So this is what I did to test my number generator. So here's the logic I had. Random goes between 0 and the biggest integer possible. Mod 19999 gives you a number between 0 and 19,998. Subtracting 9,999 from that changes that range from 0 to negative 999. And the top is now 9,999.
Oh, okay, I see.
So that literally took me probably 15 minutes to get that right. Because I'm like, no, I know how to do this, but it wasn't working. But anyway, so that's the magic of modulus and all that good stuff. Any questions on that solution or how I wrote it or why I wrote it the way I wrote it? I did not need to generate 100 million numbers. I did that just to kind of test my range. Nope. Cool. All right, so tonight we are going to go over basically two things. The first, we are going to sort these numbers. Normally, I would make you figure this part out yourself, but for sake of education, we will go through in detail, and there will be still a homework assignment based on all this kind of stuff. But anyway, we'll get to that later. So we're going to read the data that we just wrote. We're going to sort the data, and then we're going to write it to another file. That's kind of the steps I'm going to take when building the next program. Like if you think about this as a data pipeline, your first program generates the data, and then your second program is going to sort the data. So this is a chat question. Oh, I bet I can.
It's Leo asking if it's recording.
It is recording.
It's just not doing it through Zoom.
Correct. I'm not doing it through Zoom because that first week was awful on Zoom. I'm actually going to open this on my phone as well so I can also see the chats. Yeah, I know. Sorry about that. All right, there's a chat. Oh gosh, I can hear myself talking. Okay, cool. So now I got the new chat coming up on my side as well, so I can watch that. Okay, so here we are opening the file with the IF stream. I have a placeholder integer to a variable so that I can read that number into. Placeholder variable. IF stream opening the random.txt file. When we're reading from the file, it's a text file, so I'm going to read it into a string. This is different than what we did in the kind of short examples last time. We read into a character array. And then I'm going to count for fun. So same check. If I can open my file, good. If not, I'll error. And so this is the function I was trying to find last week. And it's the getLine function, like we saw from the standard input, but here we are reading from the file input, and we are getting the data into our string variable, our str variable. I'm counting, so I'm incrementing my counter, and here is where I'm converting my string to an integer. The ATOI function takes a character array, so using the C_str, C-string function on the string, returns that character array. So the ATOI function will convert that into an integer for me. And then I can print it out saying this is an integer, great. Then I can close. So this is kind of the basis of how I'm going to read that file. Any questions on this one?
Not yet, at least for me.
And nothing in the chat yet. Cool. Oh, why is there a file read error check twice? Because I copied and pasted it extra. shouldn't have done that. That shouldn't be there at the bottom. But the code ran. Good observation. Okay. Then the next step, I'm going to load them into a vector. So we talked about, this is not complete code. I'm just kind of showing the changes here. So I have created a vector called all numbers. This vector will hold integers. And all I'm doing here is I'm pushing at the back of that vector the new integer. So at the end, I'll have a vector of 1,000 integers in this case. Then I'm going to build a bubble sort. So we talked about the bubble sort a couple weeks ago. I think we were sorting arrays. Here I'm sorting a vector. Somebody want to mute? Please mute.
Please mute.
Pretty please.
You make a lot of money.
Money.
Learn how to code.
All right, let me figure this one out real quick.
Learn how to code first.
Where are my
Yeah,
participants?
you can mute.
Yeah, I can mute them.
Yeah, I think you can beat them.
Okay, it's not
I
a.
can go up somewhere.
There we go. All right, cool. So here's our bubble sort. A couple of tricks I had to do in here so I could use the indexes of the vector. Remember, a vector we can access the members of that vector, the variables in that vector by index. So I'm taking a vector pointer into this function, the sort function, so I'm not copying my vector in memory. And this was the trick I had to figure out online. I had to dereference the pointer, but the interesting part is declaring this variable, a local variable for that vector, but assigning the reference, using the reference operator to make it a reference to a vector. If you don't do this, then it's actually changing the vector wrapper, I guess. It doesn't change the data inside of it when you manipulate it. It was kind of weird. Anyway, so pay attention to that one. If you do a function like this and your output does not change, it might be this reference. So, whoops. All right, so you'll see here, my testing was trying to figure out what was happening. So I was printing out the memory location of the vector, and that's what told me that I had actually two vectors in memory, but with the same data behind it. It was a very weird scenario. So anyway, I'm printing out the address just because I did. Then implementing the bubble sort, we have to start with the length of the vector. So using the size function on the vector, I can get how many elements are in it. And I'm not going to go through the details of the bubble sort, but remember, this is the one, if you put your array left to right, it starts moving the biggest number the whole way to the right. And then it comes, it starts counting backwards from that. So the bubble sort is kind of an interesting one. You can go back and watch that video on how that one works. But the idea is that this bubble sort function, or this sort vector function, will end up sorting the vector. And then I added an output stream called sorted.txt. So now I have two file checks on purpose. One for the input file of randoms and one for the output file of sorted. So since I'm reading from one file and writing to another, I had to have both output or both file streams available to me. The while loop to read the randoms.txt file didn't change. I'm still putting it in the same vector. And this is that first vector memory location being printed out, so I could compare it to the second one I talked about. Then I call the sort vector function, passing a reference to the all numbers variable because I needed that pointer. And then at the end, I printed out the sorted numbers to the screen as well as to the output file. And then I returned. And so I have that code here. Let's see, make sure I don't have a sorted file. Can you transfer data from file to file without using a temporary variable in the program, like without using a string? Yes, you could nest a write function inside of, or put a read function inside the write function. I'll show you in a little bit. But I have to sort them. I had to read them all into memory in this case. All right, so here's that sorted function. Just showing you it's the same code. And here's I'll show you the end of my randoms file just to show that it is unsorted. And then I will run my compiled sorted program. And now the output of my sorted is in order.
Oh, that's cool.
So I have two text files. You'll see I had word count as a function for you guys to verify if you wanted to. So I have 1,000 lines in randoms, and I have 1,000 lines in sorted. So that's kind of neat. Yeah, let's finish here. All right, so the second topic is about how we organize and we build our code. So in a typical C++ program application, like if you're building a business application, you'll end up with multiple C++ files. We briefly talked about header files, .h files. This is what you store, like the class definition, not the implementation. So you can store the class public members, the public the public functions, but you wouldn't put the code in this .h file. You typically have a .cpp file with the actual code in it. So I don't think I have an example. Oh well. So if we had that, if we had a class file we made for the road vehicles or the shapes, say we had the shapes, we would have the class definitions in a .h file. We would define our shape, our circle, our rectangle, and our square in a .h file. But all of those functions like get parameter and get area would all be implemented in a .cpp file, and then you have to link them together when you compile. That's so in our C++ code, when we include things like IOStream, what we're doing is we're linking to a library called IOStream. So what we would be accomplishing if we had a .h and a .cpp file, we would be building effectively our own library. So if we had a library called sort, because we wanted to put this sort function in it, we would have a sort.h file. And in that sort.h file, we would define the functions or the classes that would be in that library. And then we would need that CPP file to have the actual code. So when we've built, can you use a program to write code to a file and then run that file as code? Absolutely. Absolutely. I was going to show you an example. Maybe I don't have it in here. Oh, I should have it there. Yeah, so let's look at that sorted file. There we go. So when I say a prototype of a function, this is what I mean. It's a function declaration that doesn't have the code that runs in that function. We've implemented the function down at the bottom of the file. So that prototype is what you could put in a .h file. Pay attention. That prototype is what you could put in a .h file. and the function below it could be in your .cpp file. And so when you have all these multiple files, you have to have a way of building them. And developers don't like to type a lot of stuff over and over and over again. We like to have macros, or we like to have scripts to do things. And so in the C, C++ world, there's an idea of a Makefile. And so a Makefile it's basically a configuration file for the program make. Make is the thing that reads a Makefile and then can execute steps. It can execute dependencies when you're building your code. It can compile like your library before your main function, that kind of stuff. So there's some dependency management built into it. And so what that looks like is something like this. This is a super, super simple Makefile where if you look on the left, things like sorter.o, sort, and clean are commands, or they are the configuration items within those. So think of those as labels. And underneath of each of those labels is a command. And so if we have a program make, let's see, I'm not going to show you what it does because this is the homework. We can run make clean, and it will remove any compiled code that we've made, because that's the command under clean. So if you think about make is the program that reads the Makefile, then you tell the command for make. In this case, I wanted it to clean what I have already built, so I run make clean. Then I have others. I have sort is a command which is going to create my sorter application. You know, if you guys watch me, when I compile things from the command line, I use the G++ program, and I get an a.out file. That is the default name for the compiled program. So when I run G++ with a -o, I'm going to specify what that compiled program's name is, and in this case, it'll be sorter. And when I want to create that sorter file, I'm compiling my main.cpp file, and I have a dependency on an object file, a .o file, which is sorter. Well, to create that sorter.o file, I have to compile my sorter.cpp file. And so this is where the dependency management comes in. So what I'm saying is for my sort compile, or my sort command, it has a dependency on sorter.o. So the notation is the command, colon, and then you list the dependencies. So in order to create sort, I have to first create sorter.o, which is created by running G++ -c sorter.cpp. -c is telling it that there's no main function in here. It's going to make a .o file. A .o is a object or a library. So that sorter.o function or command creates that sorter.o file, which is then used in my sort compile to get my final sorter function or sorter application. And then there's a default. If I just run make, it will default to the sort command, which is this command, which has a dependency on sorter.o. So it'll run sorter.o first, then sort. So I know that's kind of a quick overview of how a make file is organized and how the dependencies are laid out. But does that make sense?
Kind of.
Okay, I got a kind of.
Yeah, I agree. Kind of.
Okay. Where'd I lose you?
Could you explain the .o file a little bit more?
Uh-huh. So we start with code, right? We start with a CPP file. Homework. That is a text file of C++ code, right? When I compile it, I get a dot in the default a.out file, which if I look at the file type, it's a 64-bit executable file. So it is not a text file. Like if I try to read that as a text file, I don't know what's going to happen. It's binary data. So that is an actual executable program because it has a main function in it, right? And all C++ programs start with a, where is it? With a main function. Now let's say I have, I want to build a library that can be used over and over again in different programs. I want to build a bubble sort for an integer vector that I can use in the 10 different applications I'm going to write at work. I only want to write that code once. And so the way we handle that dependency on that code is by compiling it to a library or a .o file, which is a non-executable binary file, which can be then linked to all the other code that needs it. In this case, I am going to make a main CPP file that holds my main method in it. That'll reference that external library, which looks an awful lot like referencing those operating system type libraries, those global libraries. So if I had my own library, I could include it somehow. Like if it's a local file, I could do my sort.h. So that's how I would be including my local libraries.
Good, thank you.
All right, and so you'll see in this Makefile, I have reference to two code files. One is sorter.cpp and a main.cpp. For our homework, see, tonight was a really short night, intentionally. I want you to make this Makefile work based on the code sorting, the sorting application that we went through tonight. So this is not a coding problem, but it is a code organization problem. So you need to figure out how to take that one source file and break it up into these three files, into a main.cpp file, a sorter.h file, and a sorter.cpp file. So when you submit your homework this week, I want 5 files. I want your Makefile, which is going to literally be this, like it's not going to be anything different. I want a main CPP file. I want a sorter.h file, a sorter.cpp file, and a randoms.txt file that you generated from your program that was due tonight. Same thing due next week by Wednesday. There will be some code changes you will have to make in the when you break up the code, or when you create these other files and move some code around. So it's not really code, but it's anyway, you'll figure it out when you go through it. And then when I'm grading it, I'll make sure that each file contains what it should, and it will compile. And then when I run it, it will output your sorted.txt file that I will validate. Just clarifying, are we creating sorter.h and sorter.cpp or breaking up code already given? You are creating those files and breaking up the code that's already given. I'm not expecting you to write a sorting algorithm. I'm expecting you to copy and paste the sorting code from this slide, from these slides. So I know I went through that very, very quickly. It was intentional. Did I go too quick? Is anybody completely confused on what a Makefile is and how that code works?
Not yet.
I guess I'm confused at this Makefile that you linked, is that, we're supposed to be able to open that or something?
Yeah, so like when you, I don't know what happens when I click on it, it just downloads it.
Yeah, I get an error when I download mine.
What's that?
I get an error. Is there a certain app I need or something?
make. Ooh, that's actually a really, really good point. When you run make on your computer, what happens? Nothing?
Well, yeah, this file does not have an app associated with it performing for this action. Please install an app or it was installed.
Yeah, you don't open it like an executable file. You have to run the command make on your terminal. Is make Unix only? No, it is not Unix only. When you installed MinGW on Windows at the very beginning of class, it should have installed make with it, and I am assuming that it did. Let me check my Windows computer. Because if it didn't, then I'm going to have to tell you how to install that. How do I get to a terminal? Gosh, I hate Windows. Oh, make is not recognized. All right, let's figure out this MinGW. Okay, I'm double clicking my MinGW installer. Oh, good. Okay, cool. So when there's a list of all packages that comes up, and oh, MinGW make is in there. So I know I need to find it. How do I find it? Okay, let's see why that didn't install. Oh, here we go. Okay. On my Windows computer with MinGW, if that's what you guys installed, I ran mingw32 make.exe. Does that run for you guys? I opened a command prompt and just typed that.
I'll try it. Hold on.
Okay.
It's not working for me. Nope.
Doesn't work for me either.
Okay, do you have your MinGW installer still?
Yeah.
Open that up for me. And then on the left, you see all packages.
Yeah.
Okay, scroll down until you see mingw-make-bin.
It says it's installed online. The box is checked.
Okay, so on the bottom, when I click on it, the row, I get on the bottom tab, I get general description dependencies installed files.
Yep.
What does it say for your installed files?
I might not have the path set right because it says finds and volume files bin.
Yep. MinGW32-make.exe.
Yeah.
Okay, so that's probably not on your path.
Yeah.
If you've been using the code runner in Visual Studio Code as an example, it probably found your G++ stuff itself, and you didn't set it up on your path.
I have it set up on path. I think I might just typed it wrong, actually. Yeah, that works.
Okay, cool. And I know I have a video on my YouTube on how to set up the path, I think. or at least a link to how to set it up I found somewhere.
So we just need a bin file, make that bin.
Yeah, if you check the mingw32/make/bin in the mingw installation manager, it should install it. Cool. Yeah, so when I run that, I have it in my path, and I downloaded the Makefile on my Windows computer, ran mingw32/make, and it started to go through the commands right. So setting up that, I think, what is it? Root mingw, whoops,
Yep. Okay, that works for me.
mingw/bin. That should be in your path, in your system path. So when I say that, does everybody understand what that means on the Windows computers? Setting that in your system path? Yes. I got one yes.
Yes.
Two yeses. Anyone a no? Three yeses, positives. Yes, sir. Ooh, a good positive. Thank you, Mohammed. All right, I will take those, all the bunch more yeses. Awesome. Okay, I'll take that as enough yeses that if you don't understand that, then shoot me an email and I will give you directions or point you in the right direction to figure out how to set your path. But I'm happy now that that actually works on Windows. I am a Mac guy and it's just there. Yeah, on a Mac, I think just installing the whole C++ stuff with Xcode, the Xcode extensions, it's just there. But if it's not, again, shoot me an email. It might be a brew install or something like that. So the definition of what the homework is, clear enough for everybody? Speak now or forever. Hold your peace.
Can you explain it one more time?
Yep. So in your Git repo, the one you've been using the whole time, in a week 12 folder, I want 5 files. The Makefile, main CPP, sorter.h, sorter.cpp, and your randoms.txt. The code that will be in these 3 files is code that we went over here. This sort HW CPP file is really what you're going to be breaking up and putting into those 3 files. Your main function will be in main CPP. Your prototypes will be in your .h file. And your implementation of that prototype will be in your .cpp file, your sorter.cpp file.
So I use Windows and I checked the bin folder and I saw that I had the make, get the exact one, but min g32
Yep.
make.
Yep.
But where do we move in order to run the make file? Could you just go through again what we need to do in order to be able to run it on Windows?
Yeah, so this path, min.gw bin, needs to be in your system path.
Right. Does the make file need to be moved to
No.
the bin or?
Nope.
No? Okay.
No, so once that executable is on your system path, you can run that from anywhere. It doesn't matter if there's a Makefile there or not.
Yeah. I think in the same directory that the Makefile's in to run it.
Right. So on my terminal here, I have completed the homework in that T folder, which I won't show you. But if all of those code files were here and I run make, it would work, and I would end up with that sorter. I could execute a sorter file. On Windows, it would be like sorter.exe or something like that, maybe.
Could you just repeat that about what you're saying about the directory, that they might need to be in the same directory for it to work?
Yeah, in your when you submit your homework, your directory will look something like this. You will have a make file, a randoms.txt file, a sorter.h file, a sorter.cpp file, and a main.cpp file.
Okay. All right. Yeah, I think I understand better now.
Okay. And if you come back to it when you actually work on it and you get lost, come back to the video or shoot me an email.
All right, sounds good.
Yep. Oh, well, that's all I got, folks, for tonight. I'm happy to stick around if y'all want to talk about C++, life, or whatever. But I'm going to hit stop on my recording.